8B, hypothesis testing for a population mean or a claim about a population mean, where you have a large sample or the population standard deviation is known. Now remember that a large sample is when n is greater than or equal to 30 for our purposes with this. And the only way you have a known population standard deviation is if it says the population standard deviation is. If not, then you have the sample standard deviation. Now, with dealing with hypothesis testing, we did mention previously that we can use a p-value to determine whether we're going to reject the null hypothesis or fail to reject the null hypothesis. Now, the p-value comes from using our test statistic, and in this case, since we're dealing with a large sample or a population standard deviation is known, the z-distribution. So we can find the z-score. Remember, a z-score is found by taking x bar minus mu over sigma over the square root of n. So we can use our test statistic, the claim, the population standard deviation, and the sample size. Or if we don't have the population standard deviation, if we have a sample standard deviation but the sample size is large, 30 or more, then we can substitute the sample standard deviation. So we can use that to get a z-score, which we would then look up in the table and get either our left tail or right tail or 2 times that to come up with our p-value. Remember, if we have a left-tailed test, then the p-value is equal to the area in the left tail if we have a right-tailed test, then the p-value is equal to the area in the right tail. And if we have a two-tailed test, then the p-value is equal to 2 times the area in the tail. And remember, that area could be to the right or to the left. Just look for whichever one is less than 0.5. That'll give you the area in the tail. Multiply it by 2. And then we do our comparison. If the p-value is less than or equal to alpha, we reject the null hypothesis. And if the p-value is greater than alpha, we fail to reject the null hypothesis. So that's a quick summary of some of the things we stated in the previous introduction to hypothesis testing. So let's take a quick example of this. Let's say we want to do a hypothesis test at a significance level of 0.02. So that's alpha equal to 0.02. And we go and we use our test statistic to get a z-score. We look up that z-score in the table, and we find that we have a p-value of 0.051. Let's do that. Because remember, when we pull it out of the table, there's going to be 4 decimal places. So we have alpha is 0.02, our p-value is 0.0517. So now we can compare and say if the p-value is less than or equal to alpha, we'll reject the null hypothesis. If the p-value is greater than alpha, we'll fail to reject the null hypothesis. Well, here the p-value, 0.0517, is larger than 0.02, p-value greater than alpha, therefore we fail to reject the null hypothesis. Another example, let's say we have a significance level of 0.05, and we come out with a p-value of 0.031819. We'll do 9 because that's what I wrote. So 0.0319. Now I compare these and my p-value is less than the significance level, p-value less than or equal to. In that case, we would reject the null hypothesis. So that's going to be what we're going to do. We're going to take our p-value that we're going to pull from the table and compare it to the significance level. Well, let's do an example. That's a start. Let's go and see what actually happens. Okay, now I'm going to go over here and I'm actually going to steal an example off of a sheet of paper here. So I'm not going to write this out because you've seen my handwriting, and so that would not be wise. So I'm going to read it multiple times and I'm going to pull information out of it as I find it. So Jelly Belly claims that on average, you get more than 16 ounces of jelly beans in every 1 pound bag. 40 bags are randomly selected and weighed with a sample mean of 16.4 ounces and a standard deviation of 1.2 ounces. Make a statement about the claim at a 0.02 significance level. So that's when you're reading through it. Anytime you read through a word problem, read through it the first time just to see what it says. Read through it a second time, start pulling information out of it and see if you can figure out what you need to do. So Jelly Belly claims that on average you get more than 16 ounces of jelly beans in every 1 pound bag. So what I'm seeing is Jelly Belly is claiming that on average you get more than 16 ounces of jelly beans. They're claiming that the average population mean is greater than 16 ounces. I'm leaving out the ounces and just saying 16. That's what they've given us thus far. 40 bags are randomly selected. N is equal to 40. They're selected and weighed with a sample mean of 16.4 ounces. X bar is equal to 16.4. And a standard deviation of 1.2 ounces. It doesn't say population standard deviation, so that's got to be the sample standard deviation, 1.2 ounces. Make a statement about the claim at a 0.02 significance level. Alpha is equal to 0.02. Okay. So I've got this now, so that's what it gave me. I'm going to switch to a different color to add in some supplemental stuff that we're going to pull out of this. The claim is mu is greater than 16. Greater than. That's the alternative hypothesis. It does not include equality, so that is the alternative hypothesis. Well, if that's the alternative hypothesis, then the null hypothesis is that mu is, well, if the alternative is greater than, the null hypothesis must be everything else less than or equal to 16. So that's our null hypothesis. If the alternative hypothesis is greater than, it's pointing to the right, so it is a right-tailed test. So it's a right-tailed test. So I'm just pulling things out as we get it. The sample size is 40. We have a large sample, which means we can use the z-distribution. The sample mean 16.4, sample standard deviation 1.2. That's okay, we can still use the z-distribution because our sample size is large enough to allow us to use the z-distribution. And alpha is equal to 0.02. So one thing I'm going to do here is I'm going to give myself a little drawing. Pictures help. Our claim is that mu is greater than 16. It's a right-tailed test. Right-tailed test. So we're looking at that side. So that's what I want you to notice at this point. So we're looking at that side. Remember the area in the table, the area the table shows is always the area to the left. So since it's a right-tailed test, we're going to be looking for the area to the right, so we're going to have to subtract from 1. Okay? Now that we have this, since it's a z distribution, we're going to need to find z. Z is equal to x bar, 16.4, minus mu. Mu is the claim, 16. Over sigma, or in this case we have a large sample, so we can substitute S, the sample standard deviation, 1.2, over the square root of n, which was 40. So now we can find our z-score. So we have 16.4 minus 16 divided by 1.2 divided by the square root of 40 gives us a z-score of 2.11. I actually came out with 2.108185, etc., but remember that our table only goes to 2 decimal places, so we have a z-score of 2.11. Now let me see if I have a table there. I do not, so I'm going to quickly grab a table out of the magic drawer. Almost grabbing a table out of the magic drawer. There we go. Table out of the magic drawer. So I'm looking for a z-score of 2.11. 2.11 gives me 0.9826. So 0.9816 was it? 9826, sorry. 9826. So I'll put that there for easy access. Okay, so the area to the left is 0.9826. We are dealing with a right-tailed test, so we want the area to the right. So we want 1 minus 0.9826, which is 0.0174. 0174. So now we have our p-value. Right, the p-value is equal to the area in the tail. The area in the tail is 1 minus the area that the table gave us, so 0.0174. That's the area in the tail. So now we want to compare and determine whether we're going to reject the null hypothesis or fail to reject the null hypothesis. Our significance level is 0.02. Our p-value is 0.0174, so 0.0174 is less than or equal to 0.02. Now obviously it's less than, it's not equal to, but remember our comparison is if the p-value is less than or equal to the significance level, then we do something. If the p-value is greater than a certain significance level, then we do something. So here we have it's less than or equal to, so we will reject the null hypothesis, because that's what our stuff has told us. If the p-value is less than or equal to alpha, we reject the null hypothesis. And now we're ready to make the final statement about our claim. And the final statement always starts with the significance level at a 0.02 significance level. And I tend to write these on 3 lines just because there's 3 pieces of information that I pull from 3 different spots. So that's where I got that from. We rejected the null hypothesis. There is sufficient evidence. And that came from here, the fact that we rejected the null hypothesis. And then we come back up to here and we say, well, was the claim the null hypothesis or the alternative hypothesis? The claim was the alternative hypothesis to support the claim. So to support the claim, that coming from the fact that the claim was the alternative hypothesis. So remember, we always state our significance level. We then follow up with whether there's sufficient evidence or not, and that comes from whether we were able to reject the null hypothesis or we failed to reject the null hypothesis. And then we state whether it's to reject the claim or to support the claim. If the claim is the null hypothesis, to reject the claim. If the claim is the alternative hypothesis, to support the claim. That's what we built that little table for, with reject null hypothesis, fail to reject null hypothesis. Claim is the null hypothesis, claim is the alternative hypothesis, to bring these pieces together. So we just look and go, at a 0.02 significance level, there is sufficient evidence to support the claim. And we have the pieces. Now, that's an example. I'm going to do a slight modification to this and see what effect it has. So let me get some stuff out of the way. I'm going to use the same numbers here and get rid of the stuff at the bottom. But I'm going to make a change. And I'm going to make the claim now that Jelly Belly claims that on average there are 16 ounces of jelly beans in their 1 pound bags. So now the claim is that on average there are 16 ounces. Not there's more than, not there's less than, but there are 16 ounces. So what that does is that just changed the claim to mu is equal to 16. If the claim is that the average is equal to 16, now that claim is the null hypothesis. The alternative hypothesis is that mu is not equal to 16. The alternative hypothesis points the way to tell us what test we're going to use. Not equal splits it into two, so it's a two-tailed test. Two-tailed test. We can still use the z-distribution because we have a large sample. This, because it's a two-tailed test, we have both sides there. So we calculate our z-score and it calculates the exact same way. The claim was 16, okay. Our sample mean was 16.4. Standard deviation was 1.2 with a sample size of 40. And we come out with 0.9826. Now, because it's a two-tailed test, the p-value is going to be equal to 2 times the area in the tail. Well, 0.9826 is greater than 0.5. It's more than half of it, so that's not the area in the tail. We have to subtract that from 1 to get an area in the tail of 0.0174. But now to get the p-value, we're going to take 2 times that 0.0174, which gives us 0.0348. So now our p-value is equal to 0.0348. Remember, with a two-tailed test, we go 2 times the area in the tail. For a right-tailed test or left-tailed test, it's just the area in the tail. We just have to determine whether we have to subtract it from 1 or not. So we have 0.0348. Now, when we compare our p-value to our significance level, we have 0.0348 versus 0.02. 0.348 is greater than 0.02. Therefore, we failed to reject the null hypothesis. So we failed to reject the null hypothesis. And once we have that, we can make our final statement about the claim. And again, we pull the pieces in, always start at the significance level. At a 0.02 significance level, we failed to reject the null hypothesis, so there is not sufficient evidence. And the claim was the null hypothesis to reject the claim. So at a 0.02 significance level, there is not sufficient evidence to reject the claim. Again, not sufficient evidence and to reject the claim comes from that table that we built. And that's how we do hypothesis testing for population means, where we have a large sample where the population standard deviation is known, using p-values.